Okay, I think we're running. So I have Octave Online showing, and I'd like to show you how to solve ax equal b using the normal equations and Octave Online, of course. And so I'll just go ahead and type in my matrix first. My matrix is going to be A. This is going to be a very simple matrix. I think we did this one in class, but you put in the matrix row-wise. So I have the 2, 0 is my first row, and then I put a semicolon in to finish the first row. The second row is 0, 1, and the last row is 2, 2. And then I end the line, or I end the matrix A again with another square bracket. And if I just hit return at this point, MATLAB will display the matrix that I've been typing. So you see there that the matrix A. Okay, now if I didn't do that, by the way, I just used the up arrow key to get my A back. If I used a semicolon at the end of a line, MATLAB will suppress the output, and so it'll just tell you what you just typed. Okay, now I need a B vector. Let's just 1, 2, 3 is my B. Okay, and now I want to solve ax equal b. So we know that x hat is going to be equal to the inverse, which is inv, of A transpose times A. Remember that the transpose is this apostrophe here. It's actually the single quote key. It's next to the double quote on your keyboard. Let's see, times, and then A transpose times B. Okay, so let's see what our x hat is. There is our x hat, 1/3 and 4/3. And now just to verify, right, that we didn't have a solution, you could say A times x hat, right? And you can see that that's not equal to B, right? There, B was that value. Okay, now what I'd like to do is just to show you that the difference between B and A times x hat, which is, let's compute that norm of B minus A times x hat. Remember that this quantity should be minimized, and so in this case our minimum value is 0.8165. Okay, so now let's just get a random vector in here. Let's let x be equal to, maybe I'll say x1 equal to a random vector that's 3 by 1. Doesn't really matter what it is. Okay, and now let's go ahead and see what the norm of b minus A times x1 is. Whoop. Did I not get that right? Operation is 3 by 2, 3 by 1. Oh, is my vector x1 supposed to just be a 2 by 1 instead of a 3 by 1? I think it is. Sorry about that. There we go. And you can see that this error, right, the difference between b and ax1 is much bigger than the value that we got. Good. So that is how you would solve ax equal b using the normal equations and MATLAB. Okay, now I should say that MATLAB does have an operator built in. Let's see, I'm going to say x hat 2, and I'm going to write this as b, and I'll use this, what's called the slash operator. Let's see if I can get this right here. I think it's this one. Oops, and I'm wrong about that. I think it's maybe this one then. Is it that one? There it is. Finally found it. Okay, I should have just looked it up really quick, but okay, so you can see here, right, that if I use A slash B, then I get my I get the least square solution. Good. So MATLAB does have a built-in command for that's / here, A/B. That's / right? Backslash. That's a backslash. Okay. Oh gosh. So you can play around with it until you get an answer that comes out the size you want. If you get the right dimension, you're probably going to be okay. That's a good rule of thumb in MATLAB. Okay, so I think that's it for now. This is how you, again, this is how you solve a least squares equation. By the way, I should say that let's get a quick b value that actually does have a solution. So I'm going to go ahead and take a times my x1 here real quick, and I'm going to set that equal to b1. And the reason I'm doing this is I'm just showing you what happens if ax equal b does have a solution. Do you get the right answer, right? And so in this case, our x1 here is the correct, should be the correct answer, right? Because I just made it that way. Okay, what happens if I take, let me say, call this x2. What happens if I take that inverse of a transpose times a transpose times b2 or b1? Do you think I'll get the right answer? I did. Good. So this formula actually works whether a is invertible or not, or I should say whether we have an inconsistent system or not. Okay, so either way, that works. And by the way, the backslash also works. So if you said x2 is equal to a forward slash b1, you would also get the same answer. Good. Okay, I'll stop there. Hopefully this recording will work. Otherwise, you probably won't see it. See you later.